Hi guys, BuildZoid here, and today we're going to be doing another half-baked thermal test. This time we're going to be testing some graphite thermal pad against some very good thermal paste. So this is just Kingpin Cooling KPx, which is currently the only good paste I still have, because I've gone through all of my other good pastes. So, yeah, anyway, the thermal pad that I'm testing today is, like the thermal pad we're going to be taking a look at today is T69-40. It's a graphite thermal pad, so, you know, the same kind of thing. Like, if you, like, the whole reason I'm testing this stuff is because people have been very interested in, like, the, what's it called? The graphite pads from Cool Laboratory. So this is basically similar stuff, just made by T Global. I think Cool Laboratory uses Panasonic pads, right? So the PGS right here. And anyway, this stuff is really cheap. Like, these graphite thermal pads are really, really cheap. Like, I have, what is this? This is 300, like, this is basically 300 by 300 millimeters. So that's like, imagine like, 4 120 millimeter fans. It's bigger than that. So it's an absolutely huge slab of graphite, and it cost me 14 quid. And if you buy enough stuff off DigiKey at the same time, you get free shipping. So yeah, it's 14 quid shipped. Because I generally order a bunch of stuff at the same time so that I do reach that, you know, free shipping requirement. Other than that, of course, like the Panasonic pads are also really cheap. Like, you can get, what is that? That's like 180 by 115 millimeters, so that's huge for 6 quid. Like, I don't have a lot of the other pads just because I've heard from other people who've tested them. Also, some of you might be looking at, like, that's 1850 watts per meter Kelvin, whereas the pad I have on DigiKey at least is listed as being 20 watts per meter Kelvin. But the thing is, Panasonic only specifies the XY thermal conductivity. They don't specify the Z thermal conductivity. So if we look at the data sheet for, like, the T69-40 thermal pad that I have here, in the XY direction, it's 1300. It's 1350 watts per meter Kelvin, and in the Z direction, it's 20 watts per meter Kelvin. So, yeah, and, like, that's the thing, is just, like, it's a graphite pad. The thermal conductivity, like, from one side, from, like, one edge of the pad to another edge of the thermal pad, very high. The thermal conductivity through the actual pad, not so great. And that's ultimately why they generally lose to thermal pastes. And I fully expect this one to lose to thermal paste here right today. Because, yeah, like, I'm already holding back on the 10900K more so than I'm used to. Anyway, so that's the thermal pad I'm using. And yeah, if you want to mess around with testing graphite thermal pads, just get them off of DigiKey. You'll get way more than you'll ever need. Like, yeah, you'll get way more than you'll ever need, unless you find one that actually performs well. Which, from what, I know other people who've tested more, like, a bunch of the Panasonic pads, and they've basically said, yeah, that there's very little difference between basically all of them. They just, like, some of the really thin ones don't really do that, like, are especially bad because you just can't, they're not thick enough to fill out the gaps properly to make proper contact. But yeah, which is why I actually went for the 40 micrometers thick pad here instead of, because they do make thinner ones. But yeah, that's the one I went for because I was kind of worried that if it was significant, like, if it was too thin, it'll actually not perform at all because it won't have proper contact. So with that out of the way, let's get to the actual test. So the thermometer is measuring the outlet water temperature because we don't, like, the cool thing about water cooling and testing, like, thermal interfaces with water cooling is you don't have to worry about ambient air temperature, because the thermal interface is connecting the heat spreader to the water block. And so all we really care about is, like, what temperature is the water that is going through the water block at, right? If the temperature of the water is the same in both tests, or actually you can compensate for it, you can just subtract the temperature difference in the water, you can do a thermal test very lazily, basically. And like it's not well, actually, you can get it to be relatively accurate, but I don't think we need to bother with like properly waiting for the temperature to settle or anything like that because I expect the difference here between the thermal paste and the thermal pad to be quite drastic. And I just want to make sure that doesn't like turn off. And the 10900K that I'm testing with is set up to just 4.9 gigahertz because we will be testing with Prime 95 and no, we'll be testing with Prime 95 because Prime 95 is very hot. And in fact, it's a little bit too hot. So here's the hardware info. There's our CPU temperatures. We also want like constant power draw, right? Like that's basically the two things you have to ensure is like you have similar levels of power draw and similar coolant temperatures. As long as those two things are consistent, you can test thermal interfaces very, very quickly. So we're just going to go smallest FSTs, then go custom. I'm going to put in 64 and 64, and we're going to fire that off. This is with AVX2, and voltage is 1.15 volts, pulling 220 amps, so about 250 watts CPU power draw. And is the CPU? Oh, the CPU is not quite upset yet. So right now we're in the 90-degree range. So we'll wait for a little bit. We don't have to wait super long, but 90s at 1.15 volts is honestly not good. Yeah, so we've already got one core at 97. The water temperature's at 26 and rising. But the thing is, like, the CPU core temperatures, after the cold plate initially heat soaks, because that's the thing is, like, the cold plate, the cold plate really doesn't have much thermal mass, so it doesn't take long for that to max out in terms of temperature, and then its temperature is entirely bound to the water temperature and the water flow rate. So, yeah, and already we have one of the cores going over 100, hitting 100 degrees. Current draw is, it'll actually go up in terms of V-core power draw a little bit as the CPU temperature increases. Still at around 260 watts. Yeah, 28 degrees on the water. I should actually be writing this down. So, and that's the cold side of the radiator. That's not the hot side. The hot side's probably at like 34 degrees or something because AIOs have pathetic water flow rates. So we've got 28 degree water, and the CPU is already hitting over 100. It's fine, I have the thermal limit set to 110, so hottest core is like 102. Which, like, the way I look at this is, like, some people like to use average core temperature, but, like, in my opinion, it's like, it thermal throttles if one of the cores hits 100, like, if you don't max out the thermal threshold. Like, if you don't change the TJ max setting, the CPU thermal throttles as soon as one of the cores hits 105 degrees. Our goal with the cooling system is to ensure that the CPU does not throttle. So, average temperature doesn't mean anything if one of your cores is roasting away. Also, there's just like silicon quality variance between the cores, soldering quality variance between the cores, contact variance between basically everything in the stack up, going from the die to the heat spreader. The fact that some cores are flanked by other cores affects temperatures. So the fact that there's a big temperature difference between all the cores is kind of like, yeah, that's just how CPUs be. The more cores you have, the bigger the temperature differences will be. So what are we at? Now we're at about 102. Water's at 29. So I'll take 29 and 102 degrees. And now we're going to switch over to thermal paste. Yeah, I'll call that 102. Like, there's one core that actually hit 103, but I'm not planning to, like... actually, we're going to do /103 in my notes there. Because I could just wait for the water temperature to get up to 29 degrees. So now we're just going to switch straight over to thermal paste. I'm not going to go into the BIOS and change any settings, and so it'll run the same settings. So I don't have high... I expect, like, maybe a 10-degree drop. switching from thermal pad to thermal paste. Mind you, 250 watts is really not that much power draw for a 10900K. Also, I have the mounting hardware cranked down basically as hard as I can. Like, it literally, yeah. Man. So, go. Like, the thing is, the thermal pad does have a convenience advantage. Like, for testing memory overclocking or something, I think it's great because I don't have to worry about the, like, I don't have to worry about switching thermal paste all the time. And the reason I'm actually testing the thermal pad is because I'm working on some testing where I constantly have to unmount the CPU cooling system, and it's just super annoying to keep using thermal paste doing that. So there's our thermal pad. It's very thin, right? Very like shiny metallic, and this is just a thing with the T Global. It's some side effect of how they manufacture these. As far as I know, the Panasonic ones are a much duller gray. Anyway, let's throw some KPx on there. Stay. Please stay. There we go. Not even going to be like super accurate with my application. Well, actually, this is decent. Go. And that's probably good enough. Like, if you whack on enough thermal paste, it'll just spread out if you, get it at least into the corners initially. Especially a really, like, nice soft paste like the KPx. Like, there's some pastes which really don't spread that well on their own. So, with those, it's a bit more important, but yeah, let's throw this on there. I'm kind of worried I bent the board with how hard I cranked down that thermal pad. Anyway. I probably wouldn't even need to install all of the mounting hardware. Also, it's nice that the water temperature hasn't been dropping, so we don't have to wait for it to cool, like, heat up again. Yeah, though, if I have to crank down the thermal pad really hard just to get it to work, then actually it's going to be useless for the testing I want to do with it. Well, like the other stuff that I'm testing that I'm constantly swapping the cooling system, because the main issue there is, like, I can't actually, like, I don't have the hold down bracket for the CPU because of something I've done, and it's just like, oh yeah, it'd be nice if I could use a thermal interface that doesn't stick to the IHS and then pull the IHS out of the socket every time I take the system apart, but yeah. Anyway, so immediately our water temperature starts dropping because there's the fans on the AIO. Why did I go into the BIOS? I'm an idiot. Like, we are wasting precious heat buildup by not running Prime 95 as soon as possible. And the capture card decides to be, well, my capture card. There we go. So, where's my mouse? Come on. There we go. Mouse is up. Prime 95. Small FFTs. It's going to set it to 6464 again. Run. Now we're going to hit OK. Pull hardware info in. And, oh my god. It's so much worse. Our load voltage is 1.15 volts, or about 250 watts of power draw. The thing is, the CPU is running so much cooler that we're actually seeing leakage effects take a toll on it, right? Like, look at that. We're at freaking 80. Man, thermal pad, like, graphite pads sucks. Like, it really sucks. Like, admittedly, we're at 27 degrees right now, but yeah, that pad that I tested is not Like, it's not even meant for this. Like, I don't think it's intended to be used on CPUs or anything like that at all, but yeah, it really, and now we're at 253 watts on the CPU for a little bit there. The thing is, if the CPU is running significantly cooler, then it'll actually pull less power, so yeah, getting it back up to 260 is just not going to happen. And now we're in like the mid 80s. Highest core is like 83. Well, no, we're in like low 80s. Highest core is at 83 degrees. Water temperature has hit 28.4. So, yeah, graphite pad, garbage. At least this one is. For like high, like the thing is, if you have a low heat output CPU, it's not really a big deal, but we are testing, like, and the thing is 250 watts is not high heat output for a 10900K. Like, I've done, I've done VRM stress tests with the 10900K where it would be averaging 300 watts output power from the VRM and 360, actually, no, I think it was more than that. Anyway, like at the time I didn't have a hardware info version that actually had working VRM monitoring, so I was just going off of input power. And well, right now this is reporting that input power is what is it? Input power is 280 watts. Yeah, so we're like 80 watts off of where where I'd say a 10900K is really like maxed out. And so this is just like, oh boy. Oh, that's depressing. I was really hoping for like a 10-degree drop, but it makes sense because the thing is, if you've seen like some of the overclocks that I do on the 10900K, they're all at like around 1.25 to 1.3 load volts. And so with that kind of voltage increase, it makes sense that we needed a bigger temperature drop right here. So, oh man. I was really hoping for more out of the graphite pad. I guess I could test a bunch of the other ones at this point. They're really not that expensive, but it's just like I don't have high hopes. Because the fundamental problem with the graphite pads is that they are a solid material. They're not a fluid. So with the thermal paste, when you tighten down the mounting hardware, the thermal paste gets squished out and you can achieve potentially, like a layer thickness of thermal paste, which is like, I don't know, 1/100th of a millimeter maybe. Like really, really thin, right? Like extremely thin. And with the thermal pads, like you're just stuck using, like this is a 40 micrometer, so what else is like you could get like a 20 micrometer, 10 micrometer, but at some point like it's not going to be thick enough to like fill out the imperfections in the IHS anymore. So it's just not going to work. And yeah, I'm not sure that they can make them like compressible or anything. And again, if they make them compressible, then they'll be more fragile because this stuff is like it's paper thin, but it's actually pretty solid. It does tear, but like you won't like pull it apart or anything. Like, yeah, if I grab it like that, then I can tear it to pieces. But like you're not gonna pull it apart. It's actually very much like paper. So in that sense, where it's just like, you can pull on paper as hard as you like, it's not gonna rip, and then if you actually try to rip it, then yeah, it immediately goes. Whereas yeah, anyway, which if they made it squishier, I would assume that you would be able to pull it apart at that point. And also it would probably improve the thermal performance, but yeah, that is, like, we're at 85 degrees right now. The water temperature's at 29. Like, I was thinking, maybe a 10-degree drop. Maybe my room is really warm or something. And like no, it just sucks. it's just really not meant for cooling high heat output CPUs. So I'm still gonna use it for like memory testing and stuff because it's just like, yeah, if I want to quickly do a test where I don't care about CPU performance, then it's perfect. But if you actually care about CPU performance, I would not, like, at least this, like the T69-40 from T Global, I wouldn't try to use it. Though there are other variants, right? Like if we look at the, like there's for just the T69, we have, come on, load. So I have yeah, but the thing is just like if I organize them from highest thermal conductivity, so we have a 26, that one is, and I also want some that are in stock. So what do we have? So we have a 20 watt, and that's 70. I guess that's the thing is just like which thickness am I supposed to test? The thinnest one is 0, is actually the lowest thermal conductivity in the z-axis, which is the axis we actually care about, right? Because it doesn't matter if it spreads the heat side to side because the AIO isn't next to the CPU, it's on top of the CPU. We need to go up. So yeah, Z direction is the only direction we care about, and then, thinner thickness. But like if you do the math on that, like let's say this one, right? This is like half the thickness of the 40 micrometer pad, but it's also like half the thermal conductivity. So this shouldn't really perform significantly better. At least in theory, it really shouldn't perform any better because, yeah, half the thickness, but half the conductivity. It's slightly less than half the thickness, and it's slightly more than half the conductivity, but, like, yeah, this is not going to make a huge difference, I don't think. Then there's also the chance that at that point it's just too thin and it's not going to make proper contact with the CPU. It's also the most expensive one for some reason, so that's annoying. Then there's all the different variants of PGS. Oh my god, 0.2 millimeters. Okay, that would go very badly. 20 micrometers, which PGS unfortunately has these crazy specs, but those are just XY, they're not Z-axis, so that's not very useful. And then actually, wait, and now we have like soft PGS, and those are, yeah, but those are all 0.2 millimeters, so those are crazy thick. And those are all 20 watts per meter Kelvin, so that's no good. Oh yeah, it's not any better, and it's really, really thick, so that's just going to be a disaster. This is like the highest thermal conductivity PGS that I'm aware of. Actually, let's check out what the highest yeah, that's the highest one, so 1950. But again, that's XY, so, the CPU is below the AIO. It's not next to it, so pointless. Yeah, so that's really disappointing. Because the funny thing is like a lot of other people have tested the graphite pads, and they've all been like, oh yeah, there's like a 6-degree difference, but like this is a disaster. Like it was at 100, and like the water temperature was 29 degrees. CPU temperature peaking was 103. Here we're peaking at 85. The water's even warmer than before. It's 29.3 degrees right now, and it actually seems to have stabilized. So, yeah, the water temperature is the same, and we're down like 20 degrees almost. That is just like, if it was 10 degrees, I wouldn't feel so bad about it, but it's freaking 20. And this is why you have to test with really like, and I originally wanted to test with a 300 watt load, which is why I pulled out the 10900K. I was like, yeah, we're going to test this with like 300, some crazy amount of heat output, but you can't because it overheats. Like I was riding the thermal throttle, and I was just like, okay, well, we need to lower I just kept lowering the voltage until it was acceptable in terms of operating temperatures, and it's just like, and then you switch to thermal paste, and it's just like, oh, well, I guess this is why we don't see this is why we have thermal paste and not graphite pads. Anyway, so yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. Actually, I'd love to hear your thoughts if I should try to test more of the graphite pads from DigiKey, because I don't think they're going to be that different. I really think they're all going to be just massive disappointments of varying degrees. So, yeah. That's it. I guess I should also, well, we'll see. Like I'm still hoping that I get the use out of the thermal pad that I wanted originally, which is for one of the sketchy mounted CPUs where it's just like thermal paste is annoying to work with for that, but yeah. Yeah, so I'd love to hear your thoughts if I should test more of this stuff, because I can. It's not that expensive. It's just like it does technically eat into the AHOC budget, and like I guess I could give away the excess thermal pads, just like fold it up into an envelope and send it to people. Um, so yeah. Anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. And then there's also the AHOC Teespring store where, you know, you can buy, what is it, shirts, stickers, posters, you know, the usual YouTuber merch. And you can support me by buying some of that stuff. And yeah, that's it. So thanks for watching, and goodbye.